Hello everybody, it is I, back at it again. And today we're in with Box. We are doing complementary counting. No, not complementary, casework counting. Casework counting, and so the thing with casework is it takes a while. Many times. Sometimes it doesn't take as long. So casework counting, it's kind of in the name, you know. It's casework. So you split a problem up into cases, and you solve for each case. And we're going to be doing two problems with said strategy. So let's do it. Problem 1. I flip 6 coins. How many ways? Well, okay, let's do this. What is the probability that I flip 4 or more coins? That comes heads. That come up heads. The probability that I flip 4 or more coins heads. Well, let's think of the obvious cases here. We can think of the probability that I flip 4 heads, 5 heads, or 6 heads. Let's work backwards. 6 heads is easy. There's only one way to do that. 5 heads. Let's think. So here's a very good way to calculate the number of ways to flip coins and stuff. So let's think. We have 6 places, right? Think of it this way. 1, 2, 3, 4, 5, 6. Right? We have 6 places. Now, think about, rather than thinking I need to flip heads on this one, this, think about it this way. I need to choose 5 of these 6 places to put a heads in. 5. So there's 5. So then think about it. We're choosing 5 out of 6 tails. We're choosing 5 out of 6. So it's going to be, obviously, 6 choose 5, which is equal to 6. No, there's one way here. 4 heads. Once again, we have 1, 2, 3, 4, 5, 6. And we need to place 4 of them. 6 choose 4 is equal to 15. So 15 ways to do this one, right? That gets us 22 in total, adding them up. And then out of, how many ways are there for me to flip the 5 coins? Well, there's 2 ways for this one, 6 coins. 2, 2, and 2, right? 2 times 2 times blah, blah, blah. 64. Cancel, cancel, cancel. 11 out of 32. That's my probability. And as you can see, splitting up into cases made it much, much easier. Rather than, I don't know. Now let's do one that really would need casework and stuff. Okay. Alright, ready? How many, okay, what is the number of 5s that are written in Johnny's book when he has a 1,000-page book? On the page numbers. And so let's think about this. How can we split this up? 1,000. Okay, well, let's split it up into powers of 10, because that seems easier, because there's a lot of repetition, right? Yeah, let's do 0 to 10, 11, what am I doing? 11, oh my god, why do I want to make an H there? 200 and 101, 2, 9, 9. 0 to 10, obviously, 1, right? 11 to 100, right? How can we do this? Well, let's split that up into tens, right? 11 to 20, blah, 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 blah. And we have 2 cases within here. We have the case that the tens digit is a 5, and then whatever. Or the ones digit is a 5, right? Here, on this one, we have 10. However, we add 1 because 55 has 1, 2 5s written. equals 11, and then for the rest of them, well, there's what? Well, let's just count the tens. 10, 20, 30, 40, 60, 70, 80, 90. 8. I'm missing one. Where am I missing one? Oh, no. Oh, no, I'm not. Never mind. And 8. Now let's think about 101 to 99, right? So total 19. Let's think about this. Well, we can split it up once again into ones that have a hundreds digit of 5, or the ones that have a 10 slash a non-hundreds digit, right? And x, right? But however, x is not 5, right? And so how can we go about this? Well, let's think. 100 to 200, right? 101 to 200. Well, that's obviously going to have the same number of 5s as 0 to 100, right? Because it's not affected by the hundredths digit. 0 to 100 is 1 plus 19 is 20. (201 to 300), same thing. 301 to 400, same thing. 401 to 499, same thing. Almost done. Why am I drawing so many arrows? I'm not quite sure. 20. How many 20s is that? Well, there's 8. Did I miss any? No. So, 8 times 20. And then add 20 for 0 to 100. Plus 20 is 180. Now we need the big one. 500 to 599, right? How can we do this? Well, let's think, right? If we take away the hundredths digit, it's 0 to 99 again. And how many 5s do the hundredths digits collectively contribute? Well, we're gonna have 5 blank blank, right? 500 to 599. We subtract 499, we get 1 up to what is it? 100. So we're 100. So we're going to be contributing 1 5 for each of these numbers in the hundredths digit, and we're going to have 100 numbers. So we're going to have 100 and then plus the number that are from 0 to 99. 20. 120 plus the 180 that we had earlier is 300. Hopefully I'm correct in that. Hopefully you understand casework, you know, how it works. Essentially, you find a logical case to split it up into. And within this case, what's really necessary is that, rather than have, you know, something that you need to count all of the possibilities, which is you know, kind of hard to do. Instead, you do something much more simple. And this is kind of the gist of casework counting. Hopefully you enjoyed. This has been Box. We're going to end at 9 minutes 30. Hail regergon, I suppose.